Hi, I'm here at Innovations in Healthcare, and I'm speaking to one of the star founders. He's a co-founder of Synbiota, Dickie. Hi, Connor. Nice to meet you.
Nice to meet you as well.
So, great presentation. Tell us about your company.
Thank you. Yeah, so Synbiota is radically reducing barrier to entry for creating blockbuster life science products. So we're talking about medicine, materials, food, and fuel. And the way this works is that we allow people to create microorganisms the same way they would create an iPhone app. So instead of programming with ones and zeros to make software for your iPhone, we're programming with A's, C's, G's, and T's of living organisms. So DNA, basically, is the software of life.
This is a fascinating project, and it's happening at an event like this. What do you think about tonight's event?
It's amazing. This is my first time coming out to MTL NewTech. I really didn't know anything about it, but as soon as I got here, I felt a pretty good energy. I think there's over 200 people here tonight on a night where the local hockey team is playing, so that's pretty exciting to see a bunch of people willing to come out and see people like me talk instead of watch their favorite team.
And you just flew in from Ireland yesterday, or very recently?
I did. So I think I flew in close to midnight last night, and I don't know what time it is there. I don't know what time it is here. All I know is I probably need another coffee and another Red Bull.
And you just gave a really great presentation, so we'll let you go. Thanks you so much. It's been exciting.
My pleasure.
When you think of life science, biotech research and development, you typically think of expensive PhDs in white lab coats working in multi-million-dollar labs with Bunsen burners, pipettes, shakers, sophisticated equipment, which is cool. This is how we've produced a lot of the world's top products in medicine, materials, food, and fuel for the past 100 years or so. The problem is, using this technique, it takes years and costs millions of dollars, even billions of dollars, to bring a product from concept stage to the marketplace. So Synbiota is a web-based suite of applications that radically reduces barrier to entry to creating blockbuster life science products. So people come on our platform and they program life, the A's, C's, G's, and T's of DNA, the same way a software developer would program with ones and zeros of an iPhone or an Android app. And so teams of any size or even an individual can just at the click of a button create a virtual research institute in the cloud that comes complete with web-based custom-made DNA development tools, an electronic lab book that tracks the who's, what's, when's, and where's of your IP. But most importantly, or perhaps most uniquely, we also provide a tightly integrated marketplace that allows people to buy, sell, trade biological products themselves or the IP surrounding it. And so, we launched last October, and since then we've grown to over 1,000 users from all 7 continents across the globe. And people are starting to take notice, which is exciting. So not only people like the Department of Defense, DARPA, the FBI, National Institute of Health, Chinese government, they're noticing, but also, more interestingly, VC groups are noticing. And so there's a VC group in Cork, Ireland, where I just came back from late last night. They have created a $300,000 fund to finance top projects that are coming out of our research network. So that's pretty exciting for us. So there's a direct pipeline for us to identify exciting projects and get them funding immediately so that they can do cool things. And so in this marketplace where this group of finance people are going to be putting their products eventually, we already have products in the marketplace that are already selling. And probably the most exciting one is the one that we launched at South by Southwest, which is called Vézina Factory. And if anyone was here during the 2012 Hacking Health event that I participated in, I got up on stage like I am now and I told everybody there that in 5 years people are going to use our tools to create medicine for less than $1,000. And people were like, oh, golf clap, very good, like well done kind of thing, like this is a great idea. Well, I'm not a futurist, I can't make predictions, so I screwed up. But I erred on the positive side. It happened in 2 years, not 5 years. And so Vézina Factory is a biological kit that allows you to assemble a plasmid and then transfect a microbe. In this case, it's E. coli. And basically what you're doing is you're hijacking E. coli, which is exciting because it's a little, I think of it from my engineering background as a self-replicating bio-nano-robotical factory. But in this case, what we do is we hijack these microbes, and instead of it producing a gross, stinky film, it produces violacin, which is a promising a molecule that has anti-cancer and antimicrobial properties. And the funny thing is, it's hilarious. Sigma Aldrich, which is a big biotech company, they sell violacin for $350 million per kilo. We sell our kits for $540 Canadian. You can buy it right now. And basically, once you're done this kit, you have created a microbe that can self-replicate, and as long as you keep it alive, it will basically piss out this very expensive medicine. So that's really cool, and Forbes noticed this and said this was the most ambitious distributed science project. So we're on the way for doing cool things, and yeah, that's that. So I'll do a demo. So when you log in at first, what you get is awareness of your network of developers, and I don't like to call them scientists. I see it more like a trajectory of software development, where there's far more software developers or software engineers than there are computer scientists. And so this, supposes that future scenario, which is rapidly on its way. And so I have a listing here of all the cool stuff that's happening in my network of performers. But let's say I want to go into a project. I can, I'll choose this one. So this one actually happened today in Cork, Ireland. So this is a research project of somebody who's bought one of our kits and has created the plasmid in a unique way. And then they are basically storing all of their data so that somebody can reproduce it because they've customized it. So we go in here, there's an electronic lab book, I can see all the cool stuff, I can see who did what, and there's tags and all this typical kind of stuff. I can see who the members are. But in this case, let's go check out the sequences, and these are DNA sequences. And there's a whole bunch in here that constitute the logical portion of the kit. So the kit is actually wetware, it comes to you in the mail, it has DNA. You need tools to assemble it, but this is the software version. And so what I'll do is, I'll click this button, and then I'm going to open all of these DNA pieces. Basically, it's like little snippets of code. They're like functions of software, but it's living software. It'll pull it up in this tool here that we have. It's called Gentle. It's an open source web-based DNA design tool that we developed when our founding team, we were Mozilla fellows before this. And so we did this at Mozilla. And so what I'll do is I'll turn on this designer tool, and this will give me drag and drop functionality. So I'm going to rapidly just create a quick plasmid here. And now let's view it. Now that I have this DNA code, let's say this is a finished project, I can go ahead and push print like I would in Word, and instead of it printing out a piece of paper, like a document, it's going to print out an actual DNA molecule. And the way it does this is through technology called DNA synthesis. This is normal, this happens, this is not in the future, this happens now. And you get your piece of DNA, and then you put that in your organism, and you hope that it works. If it doesn't, you go back to the drawing board and continue. But if it works, you're making a lot of valuable products. And so tonight I talked about medicine. This technology works for any biological material, so it's medicine, materials, food, fuel, and even communication, because you can encode a text file, a human readable text file in DNA if you wanted to. And that's crazy talk, but it's exciting as well. Anyways, that's that. Come chat with me a little bit later if you want to learn more. My name's Connor.